Go through this really good single axle, 9-tip single axle, right? We talked about this. 18-tip single axle, right? This is what it is, the tandem, correct? So you are looking at this, and I want to cover viscoelasticity, viscoplasticity really quick, but I have to stop at some point, right? Yeah. Right here, the 9-tip single axle, this is 18-tip single axle, right? This is the spacing I'm concerned about. Everybody understand that, right? And then you have 26-tip trident axles. You see certain trucks are very heavy, and you have three wheels. For a given material and pavement structure, different wheel load configuration produce different stresses. More concentrated or larger stresses. We discussed this before. A single wheel will cause more damage than a dual wheel with same total load, right? Because you have one over the other. For a given load configuration, stiffer, thicker layer carries greater stress strain than softer, thinner layer, right? Remember that goes to the cone of distribution. You want the material to efficiently distribute the load, correct? Effect of one of the requirements of this course was to cover viscoelasticity, viscoplasticity, plasticity, and I want to take the time to cover that before I enter into traffic characterization, which is very, very important. How we measure traffic in pavements. So I'm going to, if you have the ability to take notes, please do so. I'm going to cover that on the board here. This is going to add value to what we're going to do later on traffic. So let's look at viscoelastoplastic behavior. So let's look at this. Let's say I take a material, any material. Okay. Can everybody online also see this? Right? Both? Okay, great. Now, if I take this material and I apply a load, let's say from time equal to 0 to t equal to t0 seconds, and I apply a constant load. So very simple test, right? I take a material, I apply a load, keep it constant for a certain amount of time. Correct? Now, we all have to recognize that we can never go from 0 to a certain point instantaneously. There's always going to be some lag, right? There's no machine that can apply it. As long as we recognize that this is physically not possible, right? But we'll work with this. Okay, so this happens with every material, every single material. And if you can understand this piece, it will go a long way. So every material will exhibit this. Okay, so this is epsilon strain. This is what happens when you apply a load. So right here, you have right here, okay, anytime you apply a material, okay, there is going to be this is a completely exaggerated. I'm going to exaggerate it even more so people online and here at the back can also see. There is going to be an elastic portion instantaneously. Okay, there is going to be a plastic portion. Let me do it the other way. There's going to be a plastic portion and there is going to be an elastic portion. Okay. They all happen instantaneously and they are time independent. That means once it happens, it doesn't change over time. Okay. Then there is something called time dependent portion. Remember, this load is applied and it stays there for a certain amount of seconds or minutes, whatever it may be. So you are going to see another one. Okay. This is again exaggerated. And there you will see a time dependent portion, and that's called epsilon VE. Okay. So once again, epsilon E is elastic, instantaneous, and time independent. epsilon P is plastic. Same thing, instantaneous and time independent. Same thing. Okay. Then there is epsilon V. It is viscoelastic, time independent, okay, but comes back over time. So let's look at this. If I have another thing happens at the same time while this is happening, there is going to be a epsilon. Does anybody guess what it is? Guess what that would be? Epsilon BP, viscoplastic. Time dependent. Fair enough? Okay. Now, so I want you to clearly understand every material will exhibit this. When you make an assumption that the material is time independent, you are just assuming that these numbers are so small that it is irrelevant. As I mentioned, in real life it happens. Everybody. So if I am standing on this, over time it is sinking. Right? And I come off it, it is still sinking, but the numbers are so small, it is irrelevant. Does that make sense? Everybody understand this? Okay. Now, as soon as you remove the load, epsilon plastic does not come back. By definition, it is permanent or plastic. Now I'm right here, right? And as soon as I remove the load, the elastic portion, epsilon, I'll just erase this for a second, make it clearer. So this is epsilon Vp, right? This one. As soon as I remove the load, epsilon E that was there, that will come down right away. Because elastic, right? Time independent, you remove the load, elastic portion comes back. Then, viscoelastic portion accumulated over time, viscoelastic portion will also come back over time. So this portion that accumulated over time, that same portion part will come back over time. Why will it not come back to this? What is that? Yes, the viscoplastic accumulated over time, but because it is plastic or permanent, it will not come back and you are left with epsilon piece. This is same as this. This is same as this. This is same as this. You can capture this and understand this breakdown at any time. You will not miss any behavior. This material is, all materials are viscoelastoplastic. Everybody with me so far? Everybody online has any questions? Okay, now if I say, please give me a strain distribution of a purely elastic material. What will the strain profile look like if I apply this load? I want everybody to try it online as well as this. What will it look like? I want you to write it on the board on your paper and tell me what it will look like if this material was purely elastic. What will the strain profile look like? I want everybody to try. Every single person online and in the year. Then someone can come up and do some artwork. I told you, civil engineering is all about artwork. Anybody want to come and draw? What will it look like? What will the strain profile look like? Come up here. Anybody, brave soul. Come up here and draw it. What will it look like? Anybody want to try? Just say it otherwise. If it's purely elastic, what will it look like? Anybody? Nobody? Say it. You've got lots to cover. Anybody online? What will it look like?
So Sandhya Rani said it looked exactly the same.
So it will look exactly the same, right or wrong? It will look exactly the same. It will completely track the load profile. It's elastic. By definition, elastic completely tracks. So that's absolutely correct. It will look exactly like the strain profile. Everything else drops. Epsilon E will come up. It will remain the same. Epsilon will. So you are absolutely correct. It will look exactly like this. Let's look at another one. If it is a elasto, let's make it a little more complicated. What if it is purely only viscoplastic? Viscoplastic only. What will it look like? What will it look like? If it's only that component, what will it look like? Anybody just say? Anybody speak up here? Online? Anybody in the back? My backbenchers are the most solid people. I believe in them. Anybody? What will it look like? The artwork.
So Sandhya Rani again said it increases till the load and remains constant.
It will increase.
It increases till the load and remains constant.
And remain constant. You are absolutely correct. Remain constant. So it goes up. Epsilon Vp went up. Only that portion went up. It accumulated over time, and it is plastic, so it will not come back. And so you can do any combination. And I just wanted to give you that flavor. All right, let's keep going. I hope you can understand this piece. Let's look at traffic. Okay. Alright, we got here last time, right? One 18-tip axle. So we are going to now talk about traffic. So we are going to talk about traffic, how you calculate traffic in pavements. And by definition, one 18,000-tip single axle will cause damage equivalent to 1. Okay? So everything is kind of normalized to 18-tip single axle. Does anybody know why 18-tip single axle? I discussed that yesterday. Why that number came up?
So it is the maximum pressure at which the tire burst.
Correct. At that, when the AASHTO road test was done, that was the maximum load it could take at that time. Now the numbers have changed. That's when the tires bursted. So that was considered. Can I erase this? Everybody got this? So let's look at this, right? So let's say I have right here, okay, 18-tip single axle. That is 8. Those who are just joining in, 18-tip single axle. There is something called equivalent single axle load, or ESAL, equivalent single axle, and that is an 18,000 pounds, 18 kips single axle load. Now let's look at this. Okay, if I have a pavement, okay, it is this thin, okay, 4 inches, and there is another pavement that is 8 inches. Okay, both are brand new pavements. Okay, with me so far. Now I have one single axle, right? So one single axle, 18 kip, go over 18,000 pounds go over this, and I have another pound going 18,000 pounds going over this. Everybody with me so far? Okay. Now let's say I have 1,018,000 pounds go over this pavement A, and I have 18,000 pounds go over this pavement B, right? A million passes, right? And let's say it causes a certain amount of damage. I'll just give a number, right? It reduces the strength. Let's say it causes this damage. Okay, it causes. I'll give a number, right? Its strength dropped by 50%. Just give some quantification of damage. So a damage amount, let's call it dA because of pavement A, right? I'm just giving an example, like some kind of damage. Okay? A simple question. If I apply same number of repetitions, nothing else has changed. The properties are exactly same, and this occurs a damage dB, right, over that number of repetitions. Which one is greater, dA or dB? dA is greater. Very simple, right? Because dA is a weaker structure, thinner structure compared to the other one. Correct? Does that make sense? Fair enough. Now, right? This damage happened, right? So what did I say? 1 million passes, right? Is that what I said? Let's go with that, right? Now work with me here. You guys are with me here. You guys agreed that dA is greater than dB. Yes? Now let's say I'm right there, right? 1 million passes became 2 years, 3 years, doesn't matter, right? Now I went from another million passes. From dA that time, I made another million passes. Okay? And I did another million passes from here. My question is very simple. Will the damage be 2 dA or less than 2 dA? You understand my question? I will repeat. I applied another million passes on pavement A. Right? You guys should be only focusing on this. Anything that is on your phone, it should be all about passes and equivalent single axis, nothing else. Right here. So, what would be the damage? dA would be less than 2 dA. Will it be less than 2 dA? More than 2 dA? Or same? Less than 2 dA. Okay, so let's look at the poll here. Somebody says dA less than 2 dA. Damage is, I apologize. Less than 2 dA, equal to 2 dA, greater than 2 dA, correct? I did another 18 million passes, correct? Okay, now look at this. I started fresh, right? I'll give you an example. Let's say you're starting in the morning, you hit the gym. You hit a couple of repetitions, you get tired, right? Now I tell you, okay, right now do the same number of repetitions. Will you be more tired or less tired? More tired. So, the moment you have applied a certain number of damage, you have created, it's like a human behavior, you don't have the same structural integrity anymore, right? That same million passes will seem a lot more, a lot heavier, right? The same exercise you do in the morning after a full days of work, that same exercise will seem a lot heavier. Does that make sense? Therefore, yes, the damage will be twice dA because you have damaged, you have broken down that pavement. Does that make sense? Same thing here. This will be greater than 2 dB because of the same thing. Does that make sense? Everybody with me so far? Can you understand this concept very, very clearly? Therefore, when we apply pavements, when we say, repetitions went up along the way next 20 years, but the damage it caused in the last 2 years is a lot more than the damage it caused in the first 2 years. Because that person is already broken down, that pavement is already broken down. Any additional you put in is just accelerating the damage. Can everybody understand that concept? So, if you can understand pavements like human behavior, you will really appreciate it better. Let's look at something else. Everybody understood that part? Okay, let's look at this now. Forget about this for a second. Can I erase this? Everybody online, okay? Let's look at this again, right here. Forget about the damage right here. I did 18 kips, right? And I did, now I dropped the number, there were 1000 passes of 18 kips, right? And I did 1000 passes of 18 kips, right? And I did the next one, 1000 passes, I bumped this load up to 36,000 pounds. Fair enough, everybody understand this? Not the same number, but I just bumped up the load. This I did 1000 passes immediately after 36 kips pound. Okay? Okay? Which one will cause less? Both of them you agree that this damage will be more than this. Everybody agrees with that, alright? Or there's no. But let's say the damage difference between these two, let's call it dA. The damage difference. This damage difference is dB. Which one will be greater? Think and tell me. You understand what I'm asking? Damage caused due to 1000 passes of 18K is a certain number. Damage caused by 1000 passes of 36 is a certain number. That difference is dA. Correct? And this same difference is dB. My question is, dB is greater or dA is greater? dB is greater. Which one is stronger? dB is stronger. So if a useless guy like me goes to the gym, he will fall apart, right? But if you have a very fit guy who is in the gym, he will be able to handle the loads very well, right? Oh, you increase my load from 18 pounds, 25 pounds of dumbbells for 40 pounds. I can handle that change, right? Because I go to the gym every day. I go to the gym once a year. Does that make sense? So this dB is going to be lot less than dA because this is a much stiffer structure. I thought you would catch that. That's 50 push-ups right there. Got it? Everybody got it? You see where I'm going there? So the amount of repetitions that happen is not a constant, it is a very complex problem. Because the impact each repetition has on those pavement is very different. Let's look at it simple. I just do simple. Asphalt, one, and concrete, another. Same thickness. Same logic applies. Concrete is much, much stronger. So the same logic applies. Concrete will be able to handle the changes between 18 kip and 36 kip very seamlessly. Correct? Asphalt will not be able to handle it. Everybody with me so far? Therefore, in asphalt, you can take pickup trucks. But if you have a concrete pavements under a certain load, is not even relevant. It's like you bicycling on a highway. It's not going to cause any damage, right? That's irrelevant. It's like me, as I keep saying, like me tapping on this wood, on this table, it's not going to cause any damage to the pavement. Can everybody understand? So, this is the basic concept of traffic. Okay, so equivalent load factor, equivalent axle load factor. Okay, so look at this way. A single 36 kip axle will cause 18 times more damage than a single kip axle. We just talked about this. I went from 18 to 36 kip. Okay, I just went to that. So you can see that a single 36 kip will cause 18 times more damage, right? So it is not even twice, it's several proportions. But this number is not constant. It is fixed to a given structure, as I just explained to you. Does that make sense? So if dA, this ratio is 18, right? 18 times damage, right? So that's what you know. So let's look at this again. EALF, equivalent axle load factor, is given by number of repetitions. I need a full board. Equivalent axle load factor EALF is given by N x over x.
I have one doubt.
Yes, please. Go ahead.
Sir, when we are considering the state to axle part, this damage of 1.0, so this 18K came like maximum axle configuration at that time. So when this has increased, so actually it is causing the damage more than 1 at present. But still we are considering damage as 1.0.
Yes. You're talking about 18 kip single axle, correct? Just 18 kip single axle, am I correct?
Yes.
Okay, I'll answer the question. Alright, to cause the same amount of damage. Alright, so 18 kip single axle is a baseline, is a complete baseline of the entire design methodology. So 18 kip single axle on any pavement, you want to start off, because you have to start from somewhere. You have to standardize something, otherwise you have too many moving parts. So yes, 18 kip single axis will always cause damage of 1 the way it's calculated. In real life, right, it will not, but somehow you have to normalize it. So right here, this is how it is done. Number of repetitions to cause a certain amount of damage of X and Y. X is the load, Y is the configuration. And number of repetitions to cause the same amount of damage of 18 kip single axle. So that is 18 kip and single axle. Okay, so I'm going to explain this a little bit more. Let's look at this. Right here. Equivalent axle load factor. Okay. Right here, I want you to look at this table. Okay. Equivalent axle load factor. I'll explain this table in excruciating detail so you can understand this concept. Right here. Always 18 kip single axle will always be 1. That's the normalization by default. Okay. Now let's understand this. These are all single axle loads, okay, equivalent axle loads, okay. And this is tandem axles, right here, tridem axles, okay. That means the 2 axles with the same load. Let's look at each of these figures. What it is telling you, I'll explain this. Let's look at a simple one, right? Let's go from 18 kip single axle to 19 kip single axle. Very simple. Correct? Everybody with me so far? So, this causes, so EALF is 1.24. Okay? So, so it is causing 1.24 times the damage as an 18 kip single axle. Everybody with me so far? Right? So, now, this entire thing was built only for a given structure. I just explained to you that depending on how old the structure is, how thick the structure is, that proportionality will differ. Does that make sense? But they did it only based on a few structures, right? So you have 19 EALF is 1.24. Okay, so this is did I get this backwards? Let me check it one more time. So here you have 1.24. So EALF of a 19 kip and single axle. That's how you write it. 19, single axle. Correct? Is 1.24. That means I have N 19. I think this is backwards. I did this exactly backwards. I'm just going to go this. I apologize for that. 18SXY, and I'm going to just change this number of repetitions to cause a certain amount of damage. damage due to 18 kip single axle. Same amount of damage. Okay, right here. So it's given by 18S divided by N 19S. So if an 18 kip single axle damages the pavement in 1000 passes, how many passes will a 19 kip single axle take? Can anybody tell me? If 18 kip single axle damages a certain pavement in 1000 passes, how much will a 19 kip single axle take? Anybody?
This equation is correct.
What will it be? Less passes or most passes?
Less.
And how much amount? 1000 divided by 1.24, right? Correct. Whatever that number is, right? Maybe 850, I'm just guessing, right? So it takes less number of passes to cause more damage. Can everybody see that? Okay, so if you go back to the table, again please. Right there, right here. So you have 18 kip single axles 1, right? 19 kip single axle 1.24, correct? Now look at this again. 18 kip single axle, but 18 kip tandem axle. What does that mean? If I have an 18 kip load, while I have 9 kip 2 loads, that's the tandem axle, but total load is the same. Can everybody see that? That's an 18 kip single axle. This is an 18 kip tandem axle. Can everybody see that? Now look at the numbers here. Let's look at this. EALF of our 18 kip tandem axle is 0.0773, correct? Is given by N18S over N18T, correct? So if I calculate N18T, what is that number? Anybody actually give me the number if I assume that to be 1000? Can actually give me, somebody can press a calculator for both of them.
This equation incorrect, bro.
Which one? Which one? ELF?
You inverse NX divided by N18, not N18 divided by the NX.
That's what I initially thought, but I don't think so. You can just give me this number, please. 1000 divided by
806.
how much?
45.
What is it?
806.
8. Don't give me decimal. Pass 806. And what is this one?
12936.
12936. So, sir, online, if you look at this, that's exactly what I thought, and I made a mistake. If I look at 19 kip single axles, will cause 806 repetitions to cause the same amount of damage as an 18 kip single axle, 1000 passes, because it is much more severe. It will fail sooner. Can everybody understand that? But an 18 kip tandem axle is 9 kips certain distance apart. Compared to 18 kip, it causes much less damage. So it will take me 12,000, 13,000 passes approximately to cause the same amount of damage as 1000 passes. Does that make sense? Everybody understand that? So, sir, I also thought the same way and I made a mistake, and I think, but I corrected myself once I saw this. Can everybody understand that? So this is how, what they do is, they take any axle that comes on the roadway, they can collapse everything to one number, 18 kip single axle, using this factor. Does that make sense? They can collapse the entire truck distribution of different loading into one single number of 18 kip single axle using this factor. Can everybody understand? And I can explain that a little bit. Look at this here. Go down here. Look at this here. I want to just emphasize this here point here. This is only for asphalt. table 6.4 is only for asphalt, and now that same factor is right here. So go down there. Up. There was something for concrete as well. It's there somewhere. So there's a separate table for the concrete as well. Let's look at the. Let's keep going with the. All right. 280 will cost 2.5 times damage. Same thing using these tables. You can get this one. Alright, I'm going to cover each of these in detail. Load equivalency factors, equivalent axle loads, truck factors, growth factors, lane distribution, average annual daily factors. Right here, number of, this was my definition right there, I should have just put there in my slides. So number of 18 kip single axle load application to cause a given damage divided by number of X kip single or tandem axle to cause the same amount of damage. Right, that's the same equation that I put up there. Right, so ELF depends on the type of damage, pavement, rigid or flexible, I just explained that. Depends on the initial damage, a brand new pavement or old pavement, right? Depends on whether it's a single axle, tandem axle, tire pressure. Depends on whether you're doing what kind of damage, how you are defining damage, and that we will do in some other session, and in this curriculum design. Alright. Let's go to some definitions. Alright, we are right here. Let's go to some definition. Average annual daily traffic. AADT, very straightforward, average annual daily traffic. That could be two-way, so on and so forth. Okay. Then you have average annual daily truck traffic. I need to write this down because I'm going to come back to some math here. It's given by AADTT, which is given by AADT times T, which is T is the percentage of trucks. T is the percentage of trucks. Average annual daily traffic, average annual daily truck traffic. In pavement design, as I just explained to you, if the load is too small, it has no impact on the damage, right? A bicycle going on a highway will cause no damage, right? So therefore, we are only focused on this number eventually. So you need to get AADT. T is all you care about because that's what causes damage on the pavement. Next is called the directional factor DF. That means percentage of traffic in each direction. Approximately 50%. So unless you have traffic going in each direction is almost the same, right? So everybody goes in one direction in the morning, on an average everybody will come back, right? On an average. There are times where they kind of, when you have a simple example is like if you have traffic consistently going in one direction heavier than leaving. Any guesses where? If you are going in a construction plant, right? Trucks coming from the construction, carrying concrete or asphalt is always heavier than the trucks going empty, right? Does that make sense? That means you may have to design both sides differently if you want to economize. Otherwise, you drive the same. Then lane directional. Why am I struggling to write fast? Lane distribution facts. That's L. So L is defined by, if this is the top, right, and these are all different lanes, right, and this is your slow lane, right, and this is your fast lane. Am I in the British system? Is this right in the British system? Or am I backwards? Either way, right? So slow lane, let's say this is the slow lane, this is the fast lane, correct? Multiple lanes, correct? Most of the traffic is on the slow lane, correct? That means that's your lane distribution factor. So many times this is almost 60 to 70% of the traffic usually coming in the slow lane. Does that make sense? Compared to the other lanes. Right? So if you have a single lane, of course it will be 100%. Right? If it's two lanes or something like that. So that's the slow lane versus fast lane, and you design for the slowest lane because the heaviest traffic comes. Let's keep going. Growth rate. This is a fun one. Growth rate. I'm going to ask you this question and then see if you can answer it for me. Traffic is growing every year, right? Let's say it increases by 4%, 5% every year. Fair enough? Okay, right here. This is year one. Construction just happened. Right? Right? So this is 1 year, right? So 0, then 1, 2, 20. Fair enough? So you're 20. Let's say the first year it is 100, right? And this growth is 5%. What is the number here after the first year? What is it?
105.
Okay, 105. What is the next one? That's it? Done? What's after that? How will you calculate?
So 1011. Yes.
Yeah, so what you do is 100 times 1.05, 100 times 1.05 squared, correct? Keep going, correct? 100 times 1.05 raised to 20, right? Fair enough? No magic there, correct? How much traffic is coming on the roadway after 20 years? I have a simple question. How much traffic do I design for? You got 100 the first year, 100 raised to 1.05 raised to 20 the last year. What do I design for?
According to design life.
Yeah, but what? 20 years. 20 years design life, but how much traffic do I design for? I'm telling you 100 first year, and then I gave you the growth number. What do I design for?
For optimal use.
I have the numbers in front of you. What traffic do I design for? What traffic number do I design for?
So maximum traffic.
Somewhere between 20 and 0.
So, say it again.
Somewhere between 20 and
Somewhere between. Why somewhere between? You're designing for 20 years.
0. Because if you design for 20 years, then cost will be very high.
But you have designed for 20 years. So you have designed for 20 years. So I'm designing for 20 years. So I'm designing for 20 years. My client told me design the road for 20 years. This is the traffic coming. How much traffic do I need to design for?
Then for 20 years.
But what is the number? What is the traffic number? I gave you the numbers.
So 100 into 1.05 to the power 20.
Power 20? This one?
Yes, sir.
Yes?
Yes.
Everybody? We have to do a community push-ups. All of them together. Is this coming? Which year is this coming? Last year. Am I designing only for the last year? Or did you answer that? Am I designing for the first year?
No, sir.
First year, second year, third year, fourth year, fifth year, up to 20 years. So what is my traffic? What does it say? This is the final year, but I'm not designing only for the 20th year. What am I designing for anybody on the online? Oh my God. All of them.
All of the
All of them, right? I have to design for 100 plus 100 this plus this plus this plus this plus this. I have to design for everything, right? The traffic doesn't start at 20th year, right? 100 plus 100 times 1.05 plus 100 times 1.05 squared all the way up to 100 times 1.05 raised to 20. That's what I have to design for. My roadway has to last full 20 years, right?
So, but if we design for the last year, so it will automatically.
But this is only coming the last year. Not all.
No, at the 20 year, the traffic will be almost double. No?
More than double.
4 times.
Many times, yes. It will be many times, you are correct. So the traffic you have designed for, if you keep adding it, it will be many times.
No,
Correct.
at the first year it is 100, right? At the 20 year it will be almost around 400 vehicles, I guess.
Then only the last year you are saying, or
Yes, sir.
all combined?
No, at the last year.
Only the last year, right? But you have to design for the second year, third year, fourth year. The roadway still exists, right? So traffic hasn't stopped on the third year. Traffic hasn't stopped on the fourth year. Traffic is still coming on the fifth year, right?
But sir, how can we design for every year?
You have to. You have to. That means you have to estimate.
So we have to construct roadway every year.
No. You're designing for 20 years. You don't want to construct for 20 years. You're designing it to last full 20 years. So right? So let's say I constructed it 2025. My traffic coming at 2045 is the summation of all this. Right? Right? All of that is coming in the next 20 years. So I have to, if my roadway has to last until 2045, it has to last for all this. Not only the 20th year, yeah.
He want to ask if there is higher
So,
traffic
sir-
at last time. Then if we design for 20th year, then it will cover all traffic.
Okay.
No,
Okay, yeah.
but sir, the problem is the traffic is increasing only at the rate of 5%, right? So the next year there will be 105 vehicles, and the next year there will be a 1010 or 110 or 111.
Yeah. Correct. But let's look at 3 years. Let's look at 3 years for simplicity. Right? If
So at the second year, it won't be going at the 205 years, right? 205 vehicles. It will be only 105 vehicles, right?
on the second year only.
Yes,
Only
sir.
on the second year.
Yes, sir.
Not the summation.
So, but you're doing the summation over there.
No, that will eventually summation. Hold on. First year is 100 years. 100 vehicles. Next year 105. Stop right there. Let's for a second stop right there. I cannot design for 100 if my design life is 1 year, 2 years. I cannot design for 105. It will fail. I have to design for 100 plus 105. You see my point?
Yes.
Let's for a second assume 2 years. For a second.
Okay.
Now you understood, right? So today is 100, tomorrow is 100, next day is 105. But if you say I only designed for 105, but I didn't account for this 100.
Growth rate 5%.
Yeah, the growth rate is 5%. Got it, everybody?
Yes.
Can I move on? Any questions? I love it. I love this discussion. Yes.
The both growth is 5% now. So 100% growth rate. 100% absorb rate. 100 plus 105. Also 100% growth rate. Plus discussion.
On that year. Yeah, so total 100 se zyada hoga, of course. But that particular year is 105. That The growth rate.
Okay.
Yes, of course. Right.
Right.
So that here it could fund it, but my roadway has to handle both the US profits. Otherwise, it's going to fail very quickly. Right? Okay, direct distribution is usually 50% in direction, which I explained. Traffic in cities are lane distribution factor. If it's 2 lane, 100% is 1 in each direction. Otherwise, you have no distribution. All right, let's look at this. How would you compare ELF of an 18 skip single axle 6 inches with a 3-inch surface layer? Higher, lower, same, and exponentially increase. Using the concepts I explained to you about the thick and thin pavement, can you go in a group and answer me in 5 minutes? The first one, how you compare ELF? I gave you the definition of ELF, right? ELF definition I gave you was NX, right? ELF definition I gave you NX over NAT, correct? Right? The question here is very simple. How would you compare ELF of an 18 skip single axle 6-inch surface layer pavement with a 3-inch surface layer? Using this definition, EALF is always compared with NAT, correct? I have said that multiple times. So if I have a thick layer versus a thin layer for an 18 kip single axle, what would be the number? ELF. Online? Anybody? Lower. Lower, you said? No. Lower. Okay. Anybody else? Lower, higher, you have what? Oh, 25% chance of getting it right? Lower. Anybody with this? EALF by definition is always compared with N of 18. Correct? Always, irrespective of the structure. Irrespective of somebody asked me that question. I said 18 kip is always 1. I showed you that table. Correct? So 18 kip, ELF of an 18 kip single axle for a 6-inch, 3-inch asphalt or concrete will always be what? Will be same. Because the definition, this is always in the denominator. But the answer, it's a trick question, but if you understand the concepts to the code, this will always be the same for an 18 kip single axle. Does that make sense? So for an 18 kip single axle, these two numbers will match. By definition, it will always be 1. Correct? Everybody understand that? Therefore, that's so far. But now the answer will drastically change for the next one. How would you compare ELF of a 36 kip single axle of a 6-inch with a 3-inch surface layer? Now you can think and tell. First one was easy. They are always the same. Alright? I gave you the example when I started this discussion about 4-inch versus 6-inch. Go back to the notes and tell me what ELF 36 single, how will you compare? Will it be same? So you're comparing ELF of 30 skip single axle. Remember the terminology, the load can be single tandem given by N 36 S over N 80. Correct? Everybody with me? So my question is simple. I calculate 6-inch and I calculate 3-inch. Will be greater. And I'm saying to you, remember the longer person can engine loads better versus the person, right? Using that, you give me the answer. Discuss among yourself and among you next week. Determine what would be the right answer. Higher, lower, same. This for 6 EAS 36S inch and S and 80 right? Can handle changes the repetition going from 18 to 6. 6-inch to handle the change better, right? To 36, right? So if I do change, if 18,000 passes, let's say, alright, if 3 is 500 passes for simplicity, correct? That is sooner. Understand that?
Yes.
Damages in less number of, right? This is a stronger. That means handle this better. You build 36,000 or closer to 5,000. Handle, it will not fall apart that easily. That number will be closer to 1,000. I'm just giving a number 900 because a stronger pavement can handle the change in loads better than a weaker pavement. Can everybody see that? This is what my students are expected to do, is to take that level of thinking, then apply it. No man. Questions? Okay. And move on.